All right. Our next project is about to build a bridge in Midland County. But really, this project is not really build a bridge. We are going to really estimate the earthwork needed and also the paving layer on the top. So basically, I'll let the team to explain this one. So basically, we are going to use some innovative ideas. We are going to use a lot of tires in this project. All right, team, get ready.
We're ready. All right, thank you. Good morning, everybody. We are BSMB Consulting. And as Dr. Yu said, our project is in Midland County. It is the design of a new bridge and a roadway through that bridge. And here we go. To introduce ourselves, my name is Brock Petrak. I'm graduating with a general degree in just civil engineering. My experience in civil engineering is with a firm in Wisconsin. I did structural engineering for them. I was working on building components and just structural analysis under design loads. However, most of my actual experience, as you can see in the top photo, is in commercial fishing. I've lived in Maine for the last 5 years and spent all my hours on the Atlantic Ocean, and I fish for lobster. So that didn't help a lot in this project, but it's a really cool story. My hobbies are mostly around the ocean, surfing, sailing. I snowboard a lot when I'm up here. I teach snowboarding lessons at Mount Ripley, and I really like to golf.
All right, my name's Stanton Schmitz. I'm from the really close town of Pendleton, Oregon. As you recognize, pretty close drive to get here, obviously. I'm graduating with a major in civil engineering, but along my way, I've picked up 2 minors, one in rail transportation, one in computer science, which actually leads to a lot of my interests, which is the railroad industry and potential automation in industries. My industry experience is a lot less impressive. I had one internship with Norfolk Southern last summer, where I worked in the South Side of Chicago on a track gang. Fell in love with the company, and they liked me so much they offered me a job, of which I've accepted, and will be starting on May 16th down in Decatur, Illinois. My interests include trains and travel. I like refereeing a lot. Those of you who are local have probably seen me ref a couple of youth hockey games. Those of you in college probably always saw me at the broomball courts. I swear I was there all the time. But I was also an avid member of REACT during my time here, serving as the president for 1 year.
Hi, I'm Mark Sheen. I'm from Blue Mountains, Wisconsin, and obviously I'll also be graduating with a civil engineering degree with a focus in transportation. I have quite a bit of surveying experience. I had 2 summer internships in Madison for burst surveying and engineering, and I did a lot of construction surveying as well as property surveying. That was a good time. I really liked that experience. My interests, I really like highway and roadway pavement design. I've also grown interest into airport planning design. And hopefully I'll be working for the Department of Transportation for either South Dakota or Wisconsin. I have offers for both. I'm just kind of deciding. I haven't decided yet which place I want to go yet. But for some hobbies, I like a lot of winter sports, skiing, hockey, snowboarding, and I also like to hunt.
Dr. You messed it up.
Sorry.
There we go. All right, so our outline for today, we're going to go over the logistics of our team, how we performed in this class. We're going to go over the project, why it needed to happen, what the background and the location are. And then we're going to go through what we did as a team. So research that we did, the calculations, planning, everything that we performed. And then we're going to wrap up by presenting our final design and our final estimate, and then we'll have time for questions. So first of all, working as a team, the challenges were fun. We expected to have a little over 175 hours for 4 of us, and we ended up with 3.5 of us completing over 200 hours. The hardest part of this class was that we started with a 4-man group And midway through the semester, our other partner, he had to leave the class. And so working through that as a team, having specific tasks for each of us, and having one of us lose that really challenged us as a team, but we got through it. But yeah, when we met, none of us knew each other. We didn't know what our experiences were, who could do soil, who could do structural. We didn't have any of that knowledge. So learning to work as a team was probably the biggest challenge we faced. And then also we had to face new software. We had to learn how to use Merle and different softwares that we use that you'll see later in the presentation. We had to get through that as a team. That was quite a challenge. So the need for this project, you can see in the picture, there is a road, South Almonder, that does not have a connection. It just stops at this creek. There's a north entrance and a south entrance and nothing over the creek. There was a bridge there years ago, and it's very light traffic in this area. It's just rural, super just light traffic. And so the need for a bridge isn't great, but it allows for creation, innovation. So this project allows for us to use all recycled materials. So the pavement going in, we'll use rubberized pavement. The backfill, we'll use a tire-derived aggregate, TDA, as the backfill for the structure. And the bridge itself will use recycled concrete beams. So it's a really cool project because there's not much need for the bridge. We're able to get creative and use recycled materials and kind of play with engineering, which is a really great opportunity. So the background here, you can see OHM was very helpful in providing us with these plans. And you can see the bridge design on the left side of this drawing. That channel will actually be excavated during construction. And the bridge running across, that's going to be recycled. You can see on the far left side, the gray hash, that will be tire-derived aggregate as the backfill. And if you look close enough, you can even see Dr. Yu down in the picture. And this is Little Salt Creek. This is where we'll be going.
All right, so one of the things we want to start with is what are the existing conditions down at Almonder Road along the Little Salt Creek? We put this under our research category because it wasn't like we could just go down there and visit. It's a bit of a drive. And we also wanted to learn about the environmental impacts of rubberized asphalt and TDA because none of us were familiar with them. We want to make sure that we're not going to do anything that's going to be overly damaging to the environment. And also, none of us had really done any roadway work before, so we wanted to know the necessary slopes necessary for rural roadways and things of that nature. Calculations and designs include the geometrics of the roadway itself, cross sections, asphalt pavements, things like that. How much earthwork is needed for the fill that was going to be put in. How much is it going to actually cost? Again, this was something none of us had really had any experience in. I was actually just taking the estimated construction class this semester, so kind of got to learn it and do it at the same time. That was a little fun. Is it even possible to construct? What's the schedule going to look like? And questions like that. So one of the first things we did with the help of our missing group member was research into the soil to help us consider the runoff, what standards will MDOT have with that. We also did end up going to Dr. Baton, local geological engineer here, who teaches the geological engineering class. He was a great resource for us to utilize and figuring out what soils would be needed, what kind of in the soils in the area and things like that. When we were looking at the shoulder width, we saw in the picture earlier, there was a lot of vegetation in the area. We wanted to know how much that we're going to need to clear and how much that we could leave. Do we need to, would it be possible like just move the trees around or that? And we also want to know like what properties was the soil. And this is again an area where both our missing team member and Dr. McCon helped. We were able to find out it was a clayey soil, so it's very moist, very compact, but and so we were able to figure out what that means for our construction, which we'll touch on later. And now for the big one, tire derived aggregate, also known as TDA. We've been referring to it as TDA thus far. This is what it is. We want to make sure that it wouldn't be harmful when put into the fill for the bridge itself. And we found some research that helped us out and shown that it was harmful when submerged in water, which allows us to interpolate that it won't be harmful when not fully submerged in water, just dealing with runoff, things like that. So therefore, it should be safe to use for the bridge. We did find out through our research that it's cheaper than general averages by about 50%. This came to us from the California government as they were pushing this tire derived aggregate because they like doing recycling and green things. So they had a lot of research done into that, and we were able to top off that. And then finally, we looked into suppliers. If it was going to be really expensive to ship into TDA because we had to get it from, say, California, then maybe the benefits weren't necessarily going to work out. And we did find out there were suppliers within 35 miles of the project, nice and close, good enough for our general need to ship it in and utilize it and take advantage of the beneficial properties.
So kind of getting into some of the design work we were looking at. The big one was the construction procedure, how these plans were kind of going to be put into action and how we are actually going to make this work. A big concern is dealing with the creek and a lot of the earthwork that we had to do. We wanted to control that sediment as best as we could, and we found that a turbidity curtain would be the best way to do that. With it in the creek, as you can see in the top there, that top diagram, is an example of a turbidity curtain, and it would kind of be placed in the river or in the creek so that that sediment can be controlled and not muck up the river. We also made our own kind of finalized cross sections. This is half of the cross section right here, just so that it can be enlarged and fit on the page. And we use this. We drew this up in AutoCAD, and we use this to estimate a lot of our material costs, which we'll talk about a little later. This is just the regular cross section. There's also another cross section for the TDA section, which would go underneath that 12-inch sub base. So yeah. So kind of getting into some of the calculations. Using the OHM plans provided, we were able to use that to assist in a lot of our material calculations. With the cross section that I just showed, that was also very helpful in getting a lot of those material costs. We were able to put them in Excel here and do all our calculations through Excel. And we also got into the cost of construction in terms of using Merle and RS means. Merle was a big help for doing that material cost estimation, and RS means was good for finding that labor factor for our cost estimate. Here's a little bit on our construction schedule. The main plan is to work from the south up. Obviously, first we have to do a lot of clearing of brush and trees to make our clearing wide enough for our cross section. We did a lot of calculations on that slope, and Dr. Berton helped us with that a lot. Just making sure that we had a wide enough area for that to accommodate that required slope. After we clear all that brush and everything, there's boulders in the creek as well that would have to be taken out. And once we have all that set up and we have the soil compacted to what we need to work, we'll work on the first supports of the bridge on the south side, using that turbidity curtain to catch any sediment in the creek. Once we finish that, we work on the other side of the creek and put our center bridge support. After the center bridge support is in, we would have to channel out some of that soil just so that the creek flows a little better and isn't restricted. Once that channel's excavated out, and put the third support, the final support on the north side of the bridge up. And then once those supports are in, we can grade our aggregates and pave our road after putting our recycled beams on the bridge, and putting the wood decking and paving all that. So here's kind of our cost breakdown. Again, we use Merle and RS means to do a lot of our costs analysis. Our big one for the material cost using Merle, we came out to about $170,000 just with cost. We used 2012 unit prices through Merle, and we factor that for inflation. And for the labor costs, we used the 2019 RS means book, and it came out with about $138,000 for that. We put in 15% for labor costs, or 15% of our labor cost was for mobilization, which came out to 20,000 there, and 33% of our labor cost was our contingency. And the main reason for this was because we haven't been able to visit the site, and there's a lot of unknowns about the current conditions of our site. Basically, we had to judge everything off the pictures that we were given, and that was kind of difficult. So we wanted to have a big contingency and a buffer for that. So after everything, our total cost came out to around $448,000 or so.
So as we mentioned earlier, this project took a lot of work. And we want to thank the people that helped us with it. Brendan Schultz is our teammate that unfortunately can't be here with us at the end, but he did contribute a lot to this project. We mentioned Dr. Vatan. He helped us with the soil mechanics of the project. Obviously, Dr. Yu and Kyle were a big help. They give us a lot of really good advice. Dr. Yu, especially having been there and knowing this project, he was fantastic. And then Craig, our advisor for the project, provided us with those plans, and that helped us along. Are there any questions?
Open the floor for questions. Lance?
One thing, I mean, I don't want to be the thing, I'm asking great questions. Are you, go back to your progress schedule, so back to the second. Just for your progress schedule, or come back from there.
Yep.
You guys thought about this and see it, you know? Why do you have the guardrail and signage prior to your final paving? In your restoration there, prior, I mean, because so you think about it, when you forget this, you know, if you're gonna put restoration in specifically after your paving, you get that last 2-3 feet, whether unless you're using a gravel shoulder or something, or you got a concrete curb. I don't think there's any concrete curbing I saw in there, so I think that you're probably gonna have to move restoration down to the end also. And one thing about most asphalt pavers is, you know, they don't like paving around things.
Right.
So if you've got your guardrail in there already, you just jumped your asphalt price up a lot. The other thing about guardrail is it's all set on elevation from your final paved surface. So it's a little bit more, it's doable. You know, you got an 1.5 inch surface coming in, you can set it, but most guardrail companies that I've ever worked with will pitch a big bitch if they gotta guess what the final grade is gonna be.
Yeah.
So just something to think about. If you're doing a road, move your restoration, or do most road restoration before final, but add some restoration after your pavement. And your guardrail should probably be after your pavement, unless you got a curve where you've got a hard fixed number.
Right.
That looks like you guys tried to use a lot of resources, which you really need to do, so good job.
Thank you.
I'll add on to what Lance was saying.
We definitely want your opinion on this one, Craig. Go ahead, Craig.
Also the soil erosion should happen before any clearing and grubbing. Any soil erosion or erosion control needs to be in place before you even move any dirt.
Right. Yeah.
Craig, I have another question for you though.
Yeah.
You know, these guys figure out the project cost is roughly about less than $500,000. I want to really ask your opinion. How much was that supposed to be?
We're actually closer to $800,000
Okay.
for that.
Okay, so you know, from your opinion right now, these guys estimate which what was too little. Was that,
I think a lot of the abutment costs and the bridge deck costs
Right.
are much higher than what they have in there.
Yeah,
Okay.
because we didn't know really what was going into the bridge. We made a lot of assumptions regarding the bridge construction. That's likely where we fell short on our cost estimate.
well, that's not your fault though, okay? Because of my goal for this project is not really design the bridge. So basically, you know, our goal is basically other than the bridge part. So I think probably okay with that, but I just want to check with Craig,
Right.
you know, how much really the budget was. So. Well, great. You know, I think the information for this project, of course, you know, Craig provided a lot of useful information. I personally only really go there, really get the pictures, you know, talk with people there. So, you know, a lot of the information we got really basically based upon our engineering judgment.
Right.
Right. So basically, I think that's, you know, you know, it's hard work, a lot of things, you know, it's very challenging. Are there any questions from other folks here in the room or online? Craig, more questions?
The only other question I had is, did you guys ever calculate how many tires you think you'd end up using?
No, we never looked into what the breakdown for how many tires per square foot or anything like that, but
Okay.
it'd be a lot.
I think the good thing they have the cubic foot, right? I remember there was numbers like saying like 4,000 square cubic foot or something.
I thought it was like 400 cubic yards.
400 cubic yards. Okay, if 400 cubic yards, basically with that number, we can calculate how much tons of tires are there.
Yeah.
So, and then you can calculate how many tires.
Yeah.
For example, eventually could be like 500,000 tires.
Yeah.
Okay.
Definitely could have done that.
Yeah, I think it'd be nice to show that. It has to be one of the biggest selling points.
Yeah.
You can probably accumulate all the tires from Midland County, just use it up in this project.
Yeah.
Yeah, I would, yep.
Yeah, that'd be fantastic. All right, if no other questions, that's all. All right, yeah, please join me and thank you for the 3 distinguished men here to finish the project.